Good morning, class. It's Wednesday here in Tel Aviv, and if everything went according to plan, we got up very, very early this morning, 3:30 or 4:30 in the morning, and we went to the airport to meet a flight of Ethiopian Jews who were arriving in Ethiopia. There were at one time 10 or 15,000, perhaps more, Ethiopian Jews that lived in Ethiopia for years and years, and nobody knew that there were these Jewish people that were black living in Ethiopia for centuries. Um, I'm not quite sure when it was discovered that they were there, but it was sometime in the early 1900s. And the Israelis began airlifting those who wanted to come to Israel because their life in Ethiopia wasn't so great. They had no running water, no electricity. They were really very poor, and life was very, very tough. And so many of these people have been brought to Israel, and we got up early this morning to be there when a group arrived in Israel. I can tell you more about it when I get back, but that's where we were. Now, on a trip earlier, I was able to visit an Ethiopian family that had been resettled to Israel, and you can see the family here in this picture. I hope it looks pretty good. You can see some of the foods. They made us some traditional Ethiopian breads and foods and coffee, and it was really interesting to hear their stories. Many of them had to walk for days and days and days to get from their homes to a city and endured such terrible hardships to make this journey. And now you can see their families are resettled and living, becoming Israelis. Um, so that's that picture. And then I thought I'd show you a picture of a place called Masada. Masada was a fortress built by the Roman ruler of Jerusalem back in the very early part of the early zeros. I mean, basically sometime between around the year zero and thereabout, this area was built. And he was afraid that he would be attacked and needed a place to go and hide. And he built this fortress at a place called Masada. When you get to Masada, it's this hill that sticks up right out of the ground. I'm not quite sure how to describe this thing, but basically it's like a cylinder, sort of an oval cylinder straight up, with no way to get up very easily. Since then, they've built a path to get up, a kind of a serpentine path. It takes about 45 minutes to walk up, which we did on this trip. And you can see here some of the ruins. But the reason Masada is so famous is that when the Romans captured and destroyed Jerusalem in 70 AD, about 970 Jews escaped, and they went to Masada, and they went to the top of Masada, and they stayed up there, and they had left it with so many supplies that you could really stay there for a very, very long time. And the Romans didn't like this at all, but they had no way of attacking them because they were pretty much in an impenetrable fortress on the top of this hill. And so what the Romans did was they built a ramp, and it took them a long time. They used slaves, of course, which they used to build everything back then, and they built this ramp, and this took months and months. And so the Jews were watching this happen and knowing that once the ramp was built to the top of the mountain, it would be over. And the day before the Romans finished the ramp and were going to attack and conquer them, they all committed suicide, and they all died, 970 people. And even that's one of the stories that's been written about for years and makes this a very famous place. It's really an extraordinary place, and the ruins are still preserved to this day. All right, back to math. Here's your word problem of the day. So see if you can do this, okay? Thousands, so number in thousands of patients seen by a medical facility can be modeled by this equation, where T is the number of years since 2000. How many patients were seen in 2005? So that's how many years between 2000 and 2005. That should tell you what T is. All you need to do then is evaluate the equation. Alrighty, you've got 2 minutes. Use your calculators. Go. Okay, so what's the answer? So we take 5 squared, it's 25, plus 2.1 times 5, that's 10.5, plus 0.8, that's 36.3. Now that's in thousands, remember. So multiply that by 1,000, you get 36,300. All right, let's move into our lesson for the day, chapter 7-5, adding and subtracting polynomials. So if we're going to find the sum of 2x squared plus 5x minus 7 and 3 minus 4x squared plus 6x, there are two ways to do it, either horizontal or vertical. If you do it horizontal, you would do it this way. 2x squared, combining your like terms, minus 4x squared plus 5x plus 6x minus 7 plus 3, and that's going to equal 2x squared minus 4x squared is minus 2x squared. 5x plus 6x is 11x, and minus 7 plus 3 is minus 4. So that's a horizontal way to do it, just combine your like terms. A vertical way to do it, and either one of these is fine, and really doesn't matter what you do when you want to do it, is just write them down. 2x squared plus 5x minus 7, and then put the like terms underneath. So minus 4x squared goes here, plus 6x goes here, and plus 3 goes here, and you just put a line here, and you get 2 minus 4 is minus 2x squared plus 11x minus 4. Same answer, just a slightly different way to do it. Either way is fine. Okay? So adding polynomials doesn't look all that hard, right? So another problem, 5x squared, and you have a plus in the middle. When you have a plus in the middle, you really don't need the parentheses. They're not important anymore. So 5x squared minus 3x squared is 2x squared. Minus 3x plus 6x would give you plus 3x. And 4 minus 3 would give you plus 1. Pretty straightforward, right? Okay, let's get to the next one. Again, not that difficult, but more terms. Let's combine our like terms. Y to the fourth, 2y to the fourth, right? Minus 2y to the fourth here. Whoops, I kind of erased that. Sorry about that. It'll be easier if I just underline them. So y to the fourth and minus 2y to the fourth. You might want to even just write it down. Minus 3y plus 2y. One thing I like to do when I'm adding these is check off each item I use, because you'll see when you're combining you sometimes forget terms. Then there's 2y cubed plus 2y cubed. That's alone. And then we've got plus 7 minus 11. Okay, I've got my terms in order. I should be able to combine them. So y to the fourth minus 2y to the fourth is just minus y to the fourth. Minus 3y plus 2y is minus y. Plus 2y cubed, there's nothing to combine that with. Plus 7 minus 11 is minus 4, and that would be the answer. Okay, hopefully that's pretty clear. Combine your terms and add them up separately. This is when it gets trickier, when you subtract. And it gets trickier because this minus sign right here applies to every term here. Okay? So let's rewrite it. 4x cubed minus 2x cubed. So it's plus 2x cubed. So I'd use that one, I'd use that one. Minus 3x squared minus x squared. So I've used that term and that term. Plus 6x, there's nothing to go with it. Minus 4 minus minus 2. So that's minus 4 plus 2. Now we can combine. The important thing is to remember to apply that minus to every item in the second parentheses. So 4 plus 2, 6x cubed, minus 3x squared minus x squared minus 4x squared plus 6x. Minus 4 plus 2 is minus 2. Okay, I hope you see that. The subtracting polynomials is a lot more difficult than adding, because you've got to remember to distribute that negative to every single term inside the parentheses. Try one more. 8y. Well, these aren't, in very good order, are they? So one thing you might want to do is reorder them, even before you start. So 5y squared plus 8y minus 10 minus y cubed plus 12y plus 7. But that's a minus y cubed, right? Okay? So we've got minus y cubed plus 12y plus 7. Okay? That's in order of degree, remember? We talked about that. So 5y squared, there are no y squared, so it's just 5y squared, right? Plus 8y minus 12y. So I've used the y squareds in my y's. I've got minus y cubed, so I've got plus y cubed. And I've got minus 10 minus 7. If we do that right, we got 5y squared. There's no other y squared terms. We've got plus 8y minus 12y, right? We have minus 10 minus 7. That's correct. And then we are just left with minus y cubed, which makes that a plus y cubed. So if we put these together, we get 5y squared plus 8y minus 12y is minus 4y plus y cubed, and then minus 17. And then to put this in the right order, we put them in order of degree. Y cubed plus 5y squared minus 4y minus 17. All right. I think at this point in time, we're going to let you go do some problems on the board, practice on your own, take your time, and the proctor has all the answers to these questions, and we'll tell you whether you got it right or wrong, and hopefully help you with your questions. I hope you have a great rest of the day, and I'll talk to you tomorrow.